using the graph, find the average velocity from 0 to 2 seconds, 0 to 4 seconds, 2 to 4 seconds, and 0 to 8 seconds. Also, find the instantaneous velocity, if possible, at 1 second, 3 seconds, and 7 seconds. All right, anytime we're finding average velocity, we're going to use the equation. Average velocity equals displacement over time, or the change in position over the change in time. All right. Another way to write this, and one that will probably be more helpful for us, is the final position minus the initial position over the final time minus the initial time. So we're going to start with finding the average velocity from 0 seconds to 2 seconds. Well, if you look at the graph that should be up at the top right corner of your screen, you'll see that in 2 seconds, so from 0 to 2, it went from position 0 to position 10. So, letter A, average velocity from 0 seconds to 2 seconds, it went from position 0 to position 10. And it's as simple as that. Then you're just going to solve. The zeros go away. 10 divided by 2 is 5 meters per second. So that's your average velocity for letter A. Letter B, we want to find the average velocity from 0 to 4 seconds. So if you look back at the graph, it still starts at 0 seconds and 0 meters. So the initial position is 0, the initial time is 0. However, now it's going to go for 4 seconds, so from 0 to 4. And at 4 seconds, if you take a look at the graph, it looks like it's at 5 meters. So the zeros once again go away. You should get 1.25 meters per second. That should make sense, because if you look at the graph from 0 to 2, it has a positive velocity. From 2 to 4, it has a negative velocity. So the average should definitely go down. We have positive velocity here. We have a negative velocity from 2 to 4. So the average should go way down. And it did. Speaking of 2 to 4, letter C asks us to find the average velocity from 2 seconds to 4 seconds. Take a look at your graph again. We can see, if you take a look at your graph, you'll see that at 2 seconds, it's at 10 meters. That's the initial position. And the initial time. Its final position is 5 meters at 4 seconds. So in this case, we don't have zeros that just cancel out. So you get 5 minus 10 is negative 5 over 4 minus 2, which is 2. And so you should get negative 2.5 as your average velocity for part C. Also makes sense. You can see the slope of the graph is negative. It should have a negative average velocity. Part D, one more part for the average velocity section. From 0 to 8 seconds. So average velocity is going to equal, at 0 seconds, it's still at 0 meters, so that's the initial time and the initial position. At 8 seconds, it looks to me, if you look at the graph, that your graph is also at 0 meters. I don't care about the fact that it went up, it went down a little, it stayed flat, it went down, it came back up. Don't care. It ends at 0. At 8 seconds, its position is 0. So this is just 0 divided by 8, which is 0 meters per second, or whatever. So that's average velocity. You'll notice Average velocity looks a lot like slope. We've talked about that before. Velocity is slope on a position versus time graph. All right, knowing that velocity is the slope on the position versus time graph, we can find the instantaneous velocities fairly easily, which is what we're asked to do in part E, F, and G. So, part E, we want to know the velocity at 1 second. All we're going to do is look at the graph and find the slope of the line where t equals 1 second. So, to me, the slope of that line, or the line, is from t equals 0 to t equals 2, and x equals 0 to x equals 10. And what you'll notice is we actually found that slope over here with the average velocities. But if we're going to find the slope of a line that starts at 0, 0 and ends at 10, 2, we use the slope formula. M equals y2 minus y1 over x2 minus x1. And then we're just going to plug in our numbers. Looks like these are zeros, y1 and x1. So we're just going to get y2 is 10 over x2, which is 2, minus 0, which equals 5 meters per second. 5 meters per second, just like we found over here, because finding the average velocity is the same as finding the slope. The other way you could have done that was by looking at the graph and realizing that the straight line from 0 to 2 means that this object, whatever it is, has a constant velocity from 0 to 2. So if the average velocity is 5, then the instantaneous velocity must also be 5 at any point from 0 to 2. That would have also worked. All right, next order of business at 3 seconds. So if we look at our graph, 3 seconds lies on the line from 2 to 4 seconds. So I'm going to draw this little graph here, 10, 2, and 5, 4. That looks like the point, or the points that make up the line from 2 to 4. And we're just going to find the slope again. y2 minus y1 over x2 minus x1. Then we're just plugging in our numbers. 5 minus 10 over 4 minus 2. Looks like we're going to get a negative number, which is good. This has a negative slope. So we get negative 5 over 2, which is negative 2.5 meters per second. We did already find that before, so again, it should be the same thing. You could have just looked at the graph, realized it's got a constant velocity, so the average of 2.5 is the instantaneous for any single point on the line. All right, that's 7 seconds. And now if you look at the graph, 7 seconds is a point. It's a corner. The graph goes down, then goes back up right at 7. So you can't find the instantaneous speed. It doesn't have an instantaneous speed. At that point, it is changing directions. So all you'd have to do is put DNE. That's it. Problem over. If you have any comments, let me know down below. You should also be able to find my email address down there. If you're not one of my students and you're still watching this, I'd be more than happy to help you. Shoot me an email. Let me know what you think. Thanks a lot. Have a good one.